Welcome to another video. So we are being told to find the shortest distance between 2 points P and Q, which are on the Earth's surface. So I'm going to take you through step by step on how to find the two distances between P and Q, following some two routes, one along the small circle and another one along the great circle. For those watching us for the first time, kindly remember to subscribe, like, leave a comment, and you can share again. So on the solution part, we have some 2 points here. P, which is on latitude 50 degrees south and 26 degrees longitude east, and Q is also 50 degrees south and 86 degrees east. So let me start by the first approach. I want to find the distance between these 2 points. I've drawn them in this diagrammatic representation. So let us start by computing it along the small circle. So I'll take you through steps, and along the greater circle I've come up with a very simple formula that will help us to get the angle between those 2 points, which will help us to use in the formula. So stay tuned. So I'll start by, along the small circle can also be referred to as along the parallel of latitudes. Along the parallel of latitude, remember this is the latitude 50 degrees. So we want to look at the distance between them, P and Q, along that line. So I'll start by finding the difference in angle. You realize that Q is 86 degrees east, while P is also 26 degrees east. So the angle difference, I'm going to take 86 degrees minus 26 degrees. Of course, I'm going to get it as 60 degrees. So that is the angle between P and Q along that latitude. So that is my longitude difference. Longitude difference between these 2 points. So to calculate my distance in kilometers, I'm gonna use the formula. There's a formula here. The distance is given by theta, which is the angle of longitude difference, over 360 times 2 times pi times r, the cosine of latitude. I've said longitude difference multiplied by 2 pi r, the cos of latitude difference. So looking at that, then it goes without saying that computing it, I'm going to have 60 over 360 times 2 times 22 over 7 times r. Let us take r to be the radius of the earth. Is usually given as 6370. It is usually given as 6370 kilometer. 6370. Yes. So using it here, 6370 times the cosine of latitude difference. I've said the latitude is latitude 50. Computing that very fast, if you have a very nice calculator, you're gonna have our answer as 42,89.54 kilometers. So that I've given you the answer of the distance between P and Q along that parallel of latitude. So just take the angle between the 2 points and then you use the formula, which is here. So I want to compute the same distance in nautical mile. So guys, in nautical mile, I'm going to use the formula longitude difference multiplied by 60 the cos of latitude difference. So I got my longitude difference was 60 multiplied by 60 multiplied by latitude difference. Remember they are in degrees. Then my answer now becomes, if you compute it, 2314.04 nautical mile. Remember this is just the same as the one for kilometers, but in a different dimension. You're being told that pilots use nautical miles. That's why it is necessary. So let us compute the area now along the great circle. So look at this diagram. PQ can be computed along the parallel of latitude, which we have done, and at the same time it can also be computed along a greater circle moving like that. You're moving from P going to where O is and then to Q. So there's a formula that will help us to get the angle difference. I'm moving from P, moving up and then to Q. It is forming a given sector there. It is forming a given sector there, and this formula will give me the answer very fast for the angle difference between them along the great circle. I'm gonna use sine over half theta is equals to the cos of latitude difference multiplied by the sine of a half the longitude difference. So guys, if you use this formula, it's gonna help you to get the angle between the 2 points P and Q measured along a very great circle there where the center is O. So let us compute it and see if we can get the theta. So sine a half theta is equals to the cosine of 50 multiplied by sine of a half the longitude difference. We got our longitude was 60, so a half of it is that. Of course, I'm gonna have sine inverse is equals to theta, sine inverse of cos 50 degrees multiply by sine 30. Doing that, you're gonna get your answer as 37.5 degrees. You just compute it in your calculator. So after having that, then I will use the formula that distance along the greater circle in kilometers as angle at the center, so the angle between the 2 points, multiply by pi, 2 pi, and then multiply by radius. So this I'll have 37.5 divided by 360 times 2 times pi, let me take pi as 22/7, times the radius of the earth. I took it as 6370. And when you compute it using your calculator, you get your answer as 4170.83. You remember in kilometers. So comparing the two, distance along the greater circle, we are getting it as 4170.83 kilometers. If you compare it to distance along a smaller circle, we got it as 4289.54. So guys, what do you realize? Of course, it goes without saying that distance along the greater circle is usually shorter compared when you move along the... Can you imagine you're being told that from P to Q along this parallel of latitude is longer compared to moving from P to the center of the earth there, or the south pole, and then to Q. That is what it typically means. So take this opportunity to leave a comment. Remember to subscribe, guys. Subscribe, like, and share. So the same distance, I can also compute it using the nautical miles, using the formula as longitude difference between the 2 points multiplied by 60 degrees, as short as that. So we got our theta as 37.5 multiplied by 60 degrees, not by 60 degrees, by 60, just 60. Then of course my answer gonna be 2250 nautical miles. Well, so we've managed to compute the distance between these 2 points, P and Q. The first approach was along the latitude, parallel of latitude, and another one along the greater circle. But most importantly, when using along the greater circle, for us to get the angle between the 2 points, whether it is on the same side or on the opposite side, then we're going to use this formula to get the angle theta. Sine a half theta is equals to cos latitude difference multiplied by sine a half longitude difference. Then it's going to give you an easier work. So up to that particular point, I want to appreciate you for watching. Kindly remember to subscribe, like, share, comment with an alternative method, and then you turn your notification on. Until we meet again, bye.